Go ahead, Dr. Cabral.
Thank you very much, Carlene, and thank you for the invitation to spend some time today to talking about effective strategies to reduce carbon footprint of dairy cattle in particular. Before we start, I like to have a little bit of an overview of what are the environmental impact that we have on the planet. So not just about greenhouse gases, but also what are other concerns that we have on the planet. We have a number of things that's going on. If you are in this green zone, so right in the middle of the picture that you see, then the Earth system can actually will be able to handle it. So that is sort of the ideal boundary that we have in order to be able to, for the Earth system to handle differences that are coming in there. So as you can see here, the application of phosphorus and nitrogen, we are now at we are exceeding our planetary boundary. So basically, what we're saying here is that the risk is now beyond the zone of uncertainty for phosphorus and nitrogen in particular, and also for biodiversity. So those are the things that are already exceeding the planetary boundary, but others are also coming up into the danger zone as well. But today we're going to be focusing mostly on greenhouse gas emissions, and the greenhouse gas emissions are now also we are in the zone of uncertainty, which means we are increasing risk. And so we're going to be talking about what contributes to greenhouse gas emissions and how we can deal with them, particularly when it comes to livestock and dairy cattle. So if you look at globally, where greenhouse gas emissions come from, about 3/4 is from the energy sector. And then we have agriculture, about 18% or so, and waste and industry. And if you zoom in on agriculture, we see that livestock and manure about 6%, and then we have agricultural soils, rice cultivation, and so on and so forth. So 3/4 from energy, and then about close to 20% from agriculture. And if you look at methane in particular, so the greenhouse gases, we have carbon dioxide, methane, and nitrous oxide, and the methane is the majority. And if you look at where methane is coming from, particularly in the US, we see that about 35% of that is coming from livestock. So this is the anthropogenic source of methane, about 35% from livestock. Within the livestock category, the way that methane is being emitted is not the same. For example, in beef cattle, almost all of it is coming from the front end because the manure is deposited in the soil. A lot of beef cattle are they are on pasture, so the manure will be exposed into air, and for methane to be formed, you need anaerobic conditions. So that's why a lot of it is coming from the front end. While in the dairy, it's almost 50-50. You have 57% coming from the front end, or the enteric emissions, and manure management also contributes quite significantly because the manure, a lot of it is handled in a lagoon. So a lot of dairies in the US, we have lagoons, so that's why we have higher contribution. And again, it depends where you are as well. Like in California, for example, with the higher temperatures, then you would expect greater emissions from manure ponds, while in northern climes where 4, 5, 6 months of the year is frozen, then you don't get as much methane emissions as well. And from the pork industry, again, quite a lot of it, close to 90%, is from the manure. So now we see that there's a lot of initiative coming up on trying to reduce the greenhouse gas emissions in particular. So for example, in the US, we have the beef industry, particularly the US Roundtable for Sustainable Beef, coming up with commitments to reduce greenhouse gas emissions, or to become climate neutral by 2040. And the dairy industry, through DMI, which represents about 80% of the dairy farmers in the US, the goal is to achieve greenhouse gas net neutrality by 2050. And similarly, a number of companies around the world have also come up with their own commitments. I'm sure you recognize quite a few of them. And Fonterra, for example, wants to be climate neutral growth by to 2030. Nestle wants to be zero environmental impact in operations. JBS net zero by 2040, and also zero deforestation by 2035. I think Trout Nutrition or Nutrico has a commitment to be 30% reduction by 2030 from per ton of feed produced. So those commitments are already out there, and so let's see what it actually means. What does, when you talk about neutrality, what does it mean? According to IPCC, when you talk about climate neutral, it is a state in which the anthropogenic activities result no net effect on the climate system. So this is about affecting the climate. Or you can also think of it as a system, in this case, the dairy production system, that's not making either net contribution to the radiative forcing or no net contribution to increased temperature. So again, when you talk about climate neutrality, we're looking at the effect it has on the climate itself. And so we have to think about how much warming we're going to get by by reducing these emissions. And so when we think about this, it means that we have to see methane and nitrous oxide and carbon dioxide in a different light, because they have a different impact on the climate system. So when people are talking about a greenhouse gas neutral commitment, then you look at a metric weighed greenhouse gas emissions. So in this case, carbon dioxide being 1, and then methane being 27 or so, and then nitrous oxide being 267. So this is over a 100-year period. But there are also other metrics that will take into account the relevant or the relative amount of time that those gases stay in the atmosphere. Methane being short-lived climate pollutant that stays in the atmosphere for 12 years or so, while nitrous oxide about 100 years, and carbon dioxide over a millennia. So their impact is different, and when you reduce those emissions, their impact on the climate is different as well. So there needs to be some sort of nuances in terms of what metrics people are using in order to define, calculate the impact is going to be on the climate, and so this is also known as net zero greenhouse gas emissions. So there's net zero effect on the climate system. So why are we focused on methane? Well, if we look at the contributions from different gases over the last 100 years, carbon dioxide has the highest, about 0.8 degrees centigrade warming. Methane has 0.5, and nitrous oxide 0.1. So although most of the emissions is from carbon dioxide, 80% of emissions in carbon dioxide, and methane concentration is not that high in the atmosphere, but its relative importance is because of this, the radiative forces it has is much, much greater than carbon dioxide. And that's why we are focusing methane. There's a lot of focus now, particularly starting from a couple of years ago in COP26 in Glasgow. There has been a lot of effort in methane. And if we reduce methane, what will help us is actually we can save about 0.3 degrees centigrade in avoided warming. So if you want to try to be below 1.5 degrees centigrade according to the Paris Agreement, by doing something with methane, we could actually get up to 0.3, so which is huge. We are around 1.1 or so now. So if we are going to hit that 1.5 or stay below 1.5, then we need to act on methane, because it has an oversized impact on the climate system. And this was made very clear by the Global Methane Pledge that was signed between the United States and the European Union. It started off as that in COP26, and then about 100 other countries joined this this pledge, which is to reduce global methane emissions by at least 30% compared to 2020 levels by 2030. And then in the last COP27 in Egypt, the number of countries increased to 150. So now we have 150 countries that have signed to this. And if they actually did this, then we will be able to eliminate about 0.2 to 0.3 degree C warming. So this is really, really important pledge that has been made. And through that, there's the Global Methane Hub now that's formed that is mobilizing a lot of resources in different sectors to try to reduce those emissions. We also have legislation in California, for example, to try to reduce methane emissions by 40% below the 2013 levels by 2030. We have only 7 years left to that, and the analysis that that was made shows that the way that we're continuing right now, it will probably get us to half of what we want to get into. So we need more. We need to do more, and that is we need to include enteric methane emissions, which I'm going to be talking about a lot. And if we include enteric emission solutions, then in California we will be able to hit that 40% reduction by 2030. So what needs to happen? These are different scenarios by IPCC. So you see the red line here. If you just continue with implemented policies right now, it's not going to cut it. So there has to be a drastic emission reduction going on, even to limit to 2 degrees centigrade, even more 1.5 degrees centigrade. But those reductions have to start right away. So we don't really have much time to play around in the reductions. I think those things need to happen right now, and we need to start right now because we really don't have much time to waste if we're going to stay under 1.5 or even under 2 degrees centigrade. We've done some quick analysis on what the impact is going to be. This is looking at reductions in emissions. On the y-axis on the left is the cumulative emissions that we see. This is in warming equivalents. And then on the right side axis is the warming that would happen since 1990. So we are comparing it to the warming in 1990. And the blue line is methane emissions, and the orange is the nitrous oxide, and the black line is a combination of both. And we can actually bend the curve for methane. And once we start implementing those technologies, and if we are able to come to reduce emissions by 50% by 2030, and then continue about 1% decline, then we would actually go into a situation where we are slowing down the warming effect. But that's offset, unfortunately, by nitrous oxide. So there has to be more work that needed to reduce the amount of nitrogen that's been incorporated, and nitrous oxide emissions need to be well below what they are right now.